All right, so this is where we left off. Values and type. Well, actually, this is where we left off. Just a quick refresher. Values and types, right? We were talking like A, B, C, D, E, F, G, hello. Those are values, but you know, they have a type. They're like a string of characters. Integers, 7, 42, 97. Integers are integers, whatever. And we also have floats. And by the way, there are a lot of other types as well. In addition to the fact we can make our own types. We can define our own types that we will get to a little later in the course. But we also have floating point numbers, which are numbers, but they have decimals. And we kind of looked at how they suck, but it is what it is. We talked about literals. This is the word we use to describe when you see a value like this. It's literally those values. And we need to be careful of the types because although they might look the same, they can have like different meaning. Like the string 1 and the integer 1 and the floating point number 1 are all different. Now, the computer would say 1 and 1.0 are probably like equal, but they are different. The computer would not say that the string 1 and the number 1 or the float 1 are equal though, because they are very different. We'll see all of this shortly. Yeah. And we also saw quickly that like, well, if you want to know the type of something, of 5, we can see, oh, it's an int. You can check the type of something by using the type function. Now, this might seem rather foolish because you're like, well, I know it's an integer. Why would I type in an integer and be like, what's its type? You're right, but sometimes you don't always have a literal. Sometimes you might have a value that's stored in a variable. And this is about where we left off last time, variables. A variable is a way we can store data in a named like location, for lack of a better term. So here I'm making the variable a, and I'm putting the value 5 in it. So after I run this line of code, line 1 here, the literal value 5 and the variable 5 are both 5. Like the variable a is storing 5, right? Even though, I mean, if you just looked at a, you wouldn't know what it is. But let me show you what I mean. A equals 5, right? Print a. Now, obviously on line 1 we know what it is, but imagine this is like a billion line program. And the very last line of it, you only get to look at the very last line, and you see that. You're like, print a. I mean, when you're looking at this code, you don't know. Again, assuming this is like hidden somewhere. When you look at that last line of code, you don't really know what's in A, but we can print it out and we see, oh, it's 5. Great, cool. So if we don't really know, we could say, well, what's the type of A? So like imagine where you don't know what the type of A is. You know it exists. Here's what I mean there. Boom. We don't know what A is, right? But we can run it. We can hit, oh, it's an integer. Let's do A and type. There. It's 5 and it's an integer. Cool. All right, cool. There we go. And then I think we basically ended with this, where I gave you that warning of the equals in many programming languages, it's not a statement of fact. It's not a statement saying that these two things are equal. It's an assignment operator. Now, when I use the word operator, it's like a symbol that means you're supposed to do something. Kind of like if you like think of addition, right? Addition is an operator. What does it mean? Well, it means add those values together, right? The equals to Python, it's an operator that says store this value into something. It's the assignment operator. Cool? Any questions about that? That was mostly like recap from last time. And I mean, the lab, you probably kind of figured this out from doing the lab anyways. So we can use variables in any place we're using values, just like literal values. Right? We see this. If you print 5 plus 6, all right, great. But if you have A and B stored in there, we can actually add A and B together because what's A? Well, it's 5. And what's B? It's 6, so when we hit run, we see, well, the first 11, and then the next 11. Now, although this program is several lines of code long, not each line of code produces output, right? It's only the ones that say produce output. I've got 2 prints, so we see 2 outputs. Cool? Any questions or anything yet? Remember though, as soon as you have a question, ask, because chances are half the people in the room have the exact same question. All right, print function, yeah, okay, cool. Here we go. Let's do this quick activity. Well, I won't give you too much time. I'll give you like 2 minutes to play around with this. Do these 5 different things. I mean, some of them we've explicitly covered. Some you're going to kind of like explore a little bit to see what happens. So take a moment, have some fun, and we'll pick up here in about a minute, maybe 2 minutes. Do you have a question or are you just stretching? What's up?
I really wasn't expecting it to be this simple. How does it know I don't mean the letter?
Because you'd have to put it in quotes.
Oh,
Yeah.
makes sense.
When it's in quotes, it's a letter. When it's not, it's looking for like something.
I remember now.
Cool.
I was really expecting figuring that one out to be harder.
No. Remember, programmers are stupid. We can only do one thing at a time, right? If you try to be smart, you're going to get it all wrong. That's good advice, by the way. Programmers are stupid. Stop trying to be smart. Be as dumb as you possibly can, and you'll get it. That's not a joke. Think about it. We have to do like everything one stupid little step at a time. We can't do anything more than that.
It's easy. It just uses new stuff. Okay. Yeah. So just make a variable to assign it for radius. Okay. And then divide by the height. Sine of the radius.
All right. So the first one, assign various values of different types to some variables. All right. So A equals 1. B equals 2.5. C equals, hello, nope, not that. And yeah, good enough. All right, cool. Looks good. All right, so try adding variables of the same type. Okay, so I don't know, let's do AA equals 2. BB equals 5.5, and CC equals whatever. By the way, the names of these variables, you can name a variable almost whatever the hell you want. So don't think like, oh, why AA? Did that have some special meaning? No, it's because I'm lazy. That's literally it. Why AA? I don't know, I called that one A. Good enough. And I already used B, so whatever. So that's why. Don't read too much into that. All right, so here, I'm going to go down to a separate box. If I go here, what's the first question? Try adding variables of the same type. All right, print A plus AA. We already saw this. I hit run, we see 3. Why? Well, A is 1, AA is 2, and so we get 3. And I see that I lost something here, so let's do, there, fun. Cool. Let's do B and BB. That's interesting. But remember, we kind of saw that floats suck, so I don't know, maybe this is a funny little rounding thing, but whatever. And then C plus, whoops, CC, and we see all that nonsense. You might remember from last time, addition does work on strings, but it has a different meaning. This is what we call so this right here, this little plus symbol, that's an operator, right? You've been familiar with this operator since you were this big, right? In school. And it has a meaning, but its meaning is context sensitive. That's a fancy way of saying, well, it really depends on what you're trying to add together. You try to add 2 numbers, well, that's addition. You try to add 2 strings, that's concatenation. It has a different meaning depending on its context. Cool? I think it's kind of you might not love it, but it's probably you'd probably at least concede it's somewhat intuitive. What does it mean to add 2 strings together? Stick them together. Okay. Right? It's not that far-fetched of an idea. All right. The next one is add things of a different type. So let's do A and B. Why is it doing that? I wonder if Python's trying to be too helpful and it's like rounding or something. This doesn't make any sense to me. You know what? You want to know why? I fell for a common problem. First of all, if you didn't notice what happened, I was hitting run and I was just getting the value 3. Does anyone actually have any idea why that was happening?
Needed to run it, some variables updated.
Exactly. I had it like this, right? And if you don't have anything after the dot, it's going to assume it's a 0, right? And I hit run. Then I went down here and I hit run. And I saw 3.0. And when you look at this code right here, that makes perfect sense. 1 plus 2.0 should be 3. Now, you might also wonder, how come it's 3.0? How come it went to a float, not an integer? You added an integer and a float. Why wasn't it just 3? Why was it 3.1? Well, first, because it was designed like that. Second of all, the intention behind the design is, you can get more precision with floats. So when you have something that's less precise and more precise, it's just going to just go to the more precise thing, just because it expands for you. So just FYI, something you'll just get used to. Now, I did go here and I typed something like this though, and I went down here and I hit run again. But we see that clearly this is not A plus B, right? Can we see that? Do we agree? Well, what's going on? Well, I never reran this block. So as far as Python, or as far as Colab in Python is concerned, the value of B was what it was the last time I hit run, which was 2.0. Okay? This value will not update until I run this cell. Now, we actually told it B's new value, and I hit run, and there we go. Yes?
Is there a point to having them in 2 different
Not really. I'll take this as an opportunity to talk a little bit about this style of programming. So this style of programming is called notebook style, and it allows you to break your code up into chunks like this, which does have some value for some people. What's nice about it is it gives you a chance, like if you're taking notes in class or something, this is often really handy because you can have these nice blocks. And then you can even add like text, and you can be like, the above code is awesome. And then like, so you can add like notes in between these blocks. So it's just like a style of programming. It's a really popular style for certain types of programming. Like when your end goal is like more like data science, let's say, this is a very popular strategy. But there's other styles where you wouldn't have blocks like this. But one of the catches of having blocks like this in this notebook style is you have to be careful about if you change anything up here, you got to rerun it to make any of the changes actually take effect. Cool? All right, so let's just get rid of that. Cool. All right, so that's why it was going funny. Now, finally, A plus C. Well, Python's saying I can't unsupported operand types for plus. Who here remember? Can we? Yeah.
Is there any way to see the current values of all the environment variables?
So, in certain environments there is. There might be. View. There might be in Colab. I can't think of it off the top of my head. On certain environments, there absolutely is. You can go into like debug mode and it'll like show you everything. But but there's usually like some steps involved with that. The easiest thing to do is just always just print it out. When in doubt, print it out. Like, what is it? Oh, it's a 7, right? That's all. So his question was, like, let's say we're here and I didn't hit run. And correct me if I'm wrong, but I believe this is your question, right? So you look here, right? And as of right now, I actually have no value at A and C. I have no idea what A and C are. I'd have to go like look and maybe calculate some stuff to figure out what it is. So I have no way of knowing what it is. I can find out what it is by hitting run though, right? By like, okay. But actually, I mean, here it's not going to work. But let's say B, right? So we see the result, but then again, I never really know what A and B is. I know what their sum is, but I can't find out what A and B is. So if you really want to know what it is, you could just print A and like I suppose on one hand this might seem obvious, but it's kind of not, right? You just got to think like, well, what is it? Print it out. Find out what it is. There's nothing wrong with adding extra lines of code. And then once you find out what it is, you're like, okay, yeah, fine. You can get rid of them. It's just fine. There are certain tools one could use where you could be like inspecting these values. So you would kind of get a sense of what they are before you hit run, but we're not really going to worry about those right now. That gets a little bit complicated. But good question. Now going back to this particular problem, why is it yelling? Well, first of all, this is an operator. An operand is the fancy word that says like, well, the values that you want to apply this operator to. Okay? So this is saying the operands, we got a problem here. I can't apply plus to an integer and a string. What does it mean, as far as Python's concerned, it's like, well, what does it mean to add the number 1 and hello together, right? And you might say, well, I mean, why doesn't it know? And if you ask that question, I ask you, fine, you tell me. What does it mean to add the number 1 and hello together? What should it do? I don't know. It's not really clear to me, is it? Maybe it's clear to you, but if it is, I don't know. It wasn't clear to the Python people. So it's just saying, this is effectively saying, Python is telling us, I can't do that. That's not a thing. If you really wanted it to be a thing, you could actually write code to define it to work just fine. But as it is, it ain't going to work. So don't think like, oh, how come it didn't know? Well, what could it possibly mean? What's 7 plus soup, right? Like, that's a ridiculous question, right? That's not a thing. Of course, you could also say, like, well, but, I mean, you could add strings together, and one might want to make the argument like, well, what does it mean to add strings together, right? Someone had to say, well, it means concatenation. Fair enough. So why is it the case that adding A plus C, someone could have said, well, obviously, if you want to add an integer and a string together, it means something, right? Which, fair enough, that's an interesting point, but to me, like, and you can make that argument. At the end of the day, Python is the way Python is. So if you're mad about it, take it up with Python. But the addition for strings, personally, I feel is a little bit like, it's more intuitive. I think people find it more intuitive. What does it mean to add strings together? Stick them together, right? Put them together. Concatenate. Where mixing the types is kind of funny. But, like, if you have the string C, like, you could also do A times B, right? Oops, extra parenthesis. And that works just fine. But can I multiply strings together? No, you can't multiply sequences of non-int of type strings. Like, what does it mean to multiply two strings together? It's kind of weird, right? But oddly enough, you can multiply a string and a number. It means like basically concatenate it x like that number of times. Why? Someone made it like that. Like, it kind of makes sense. And is this your question? What happens if you do AA times C? I guess it works just fine. Yeah. Oh, let's see what happens. What if we do B? Nah, doesn't really make sense. But I'm guessing you're kind of left going like, yeah, that is kind of funny. I guess maybe it could have taken the string and found the proportion. That's too many steps. Now we're just making it overly complicated. If you're thinking to yourself, though, how on earth would I have been expected to know that? You wouldn't have been. You got to learn it. And this is something you're just going to like pick up as you go. It's this way. There's some intuition behind it, like there's method to the madness, but you still got to learn it. So don't expect this to have been immediately obvious. All right, cool. And then this was the big one. Who tried this and saw like 5 equals A? And you see this. Actually, the error messages are getting better. So, what is this telling me? First of all, what is it saying? Cannot assign to literal here. This is the literal A. Or A. Literal 5. Right? Assignments always, listen up. Assignments always go that way. You take the value on the left-hand side and you put it to the thing on the right-hand side. Always. There's no switching it. It's the way it is. So, what this means is take the value of A, which, I don't know, we set it to 1 or something, right? And put it into the literal 5. Make the number 5 equal 1. Python's telling us you can't do that. What are you doing? Stop it. That's why it's mad at you. It's not going to work. Now you'll see, this is kind of neat. This actually, I think, is pretty new. Maybe you meant this. Equals equals is an entirely different operator. Does anyone want to take a wild guess what that means? I mean, guess. If you know what it is, I don't want to know. I want to know you. I want someone to guess. That one is a statement of equality. That is like the equals you're used to from math, where you could say print A equals 1. Well, that's true. Cool? Does A equal 2? No, it doesn't. It's false. Because 1 is not equal to 2. Pretty neat, right? Yeah.
Is that because we set A as 1 earlier?
Absolutely. Absolutely, absolutely. Like, does A equal AA? No, it doesn't, because A and 1 and 2 are not the same. Yeah. We could also say, does 1 equal 7? But, I mean, that's just literals. That's always going to be false, right? Yeah. That's exactly what it is. This is, for those of you that are familiar with programming or some other forms of mathematics that are ultimately rather elementary and trivial, but you probably don't really, you don't really learn it in high school very much. This is like Boolean logic, where you just take things that are true and false, and there's some operators you can apply to them, and you can calculate, was that true, was that false, yada, yada, yada. We're going to learn all about these very shortly. But yes, it is a Boolean. In fact, this is a whole new type called a Boolean. Or I think Python calls it bool because Boolean is just too much. Yeah?
Could we create like a math equation in that then with variables?
So, it really depends on what you mean. And I want to circle back to that question once we get to the next topic, because I have a feeling the next topic is really going to be what you're actually asking, but I could be wrong, so if I'm wrong, I want you to ask again after the next topic. Deal? Cool. I mean, ultimately, yes, but you can't really use it like an equation. For that, we want something called functions, which we will learn all about very shortly. Anyways, and how do you display the contents of a current variable? Print it out. Just print it out, you're good to go. Okay, any questions? By the way, those questions, phenomenal. I love those questions. Keep them coming. So any other questions about what we just played around with? All right, now, naming variables. Look, I know that like here I used A and AA, B and BB, C and CC. These are terrible variable names. And I'm going to tell you something too. Since you've been about maybe this big, you've learned like algebra, right? Solve for x or something, right? We always use x as some like variable, right? And depending on what we're doing, x might have different meaning. And the more you learn about math, suddenly the different types of math and the context that you're in, like A, what does A mean? Well, if you know that A means this, obviously, because blah, 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 right? Like you kind of know. I'm going to tell you something. Mathematicians, physicists, they're terrible at naming their variables. Absolutely awful. They're always using single letters to mean something. That's absolutely terrible. Computer scientists, if you're any good, you will never, ever, 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 ever do what I just did. A, B, and C are great variables for very, very quick and dirty, just playing around, dicking around with some stuff. As soon as you're writing actual code or something, what is that variable? Every value is going to have a meaning, right? What am I calculating? I'm calculating density. Call your variable density, right? Don't call it A. And the reason you call it density is, here is one of the #1 things new programmers often miss. Computer code is it is absolutely not for computers. It's not. It's for humans. Computer code is designed to be it's for humans. You write it. If I give my code to someone else, another human, I want that human to be able to read it and understand what it's doing. Your code must be understandable. Having your code give you the correct answer, sure, that's great and all. Having your code giving you the correct answer and is understandable, that's what you need to do. Just getting the right answer, I don't care. It has to be good code as well. So if your code is full of terrible variables, where if I look at your code and I go, what the hell is A? What is X? What is C? I won't know. You want your code to be as self-explanatory as possible. Now, why do I say computer code is not for computers? Obviously, you write the code and the computer runs it. That's not right. There's actually a separate program, a translation program, that will take your code and convert it to what computers use. The zeros and ones and everything. That's what the computer uses. Computer code is not for computers. It's for humans. Contrary to what everyone always thinks, computer code is for humans. You want to write it as human as possible. So your variable, if you have something that you're calculating density, call it density. Why? Because then when you give me your code and I see a variable called density, I don't have to think to myself, what does this variable mean? Assuming you're not trying to trick me, I see it as density, that's probably density. D, better than something like this, but that's still not very good. This is good. Good, good, good. Often programmers think like, you know, I think maybe it comes from like the old culture of like the engineering and technical limitations of what computers were like in 1960. where your screens were very small. You only had like 14 characters along your screen, right? Because the technology sucked back then. And you didn't have any room on your computer, so you needed to make sure your programs were small and like tight so there was no extra space wasted. So you would use variables like A, D, and whatnot, right? You want it to be as small as possible. Look, it's not 1960 anymore. We've got massive amounts of space. You don't need to be worried. You can fit as many characters on the screen as you want by just like zooming out. I probably, but anyways, why is it not working? There, look, I can have as many characters on the screen as I want. I don't need to be worried about long variable names or anything. So have good variable names. When we get to functions, have good function names. Have good method names. Have good class names. Your code needs to be as self-explanatory as possible. As soon as your code is confusing, you want it to like, stop it. Programmers are stupid. If your line of code is doing more than one thing, you're doing it wrong. If your line of code isn't immediately clear, you're doing it wrong. Don't try to impress me with how smart you are by making your code as complicated as possible. That makes you a bad programmer. Don't do it. Keep it as simple and straightforward as possible. Now, all that said, this is more of an art than a science. This is a skill you develop over time. You're not going to be writing the cleanest, most beautiful code in the world on day one. It's not going to happen. But that's what you want to work towards. Cool? Cool. All right. So pick a good variable name. There are some limitations, though. There are some reserved words in Python that you can't use. For example, if I say def equals 5, and I hit run, it's going to say, can't do that. Def has a special meaning that we're going to see shortly. So because that's a special word that Python, it's like a special keyword, you can't overwrite it. And Python will stop you. But there are other things you need to be really careful about. For example, you can say, well, print equals 7. Perfect. Great. Print is 7. The variable print is 7. Python didn't get mad at me, but you're going to get mad at Python when you inadvertently do something like this, and then down here you go, okay, print out the hello. And it's saying int object not callable. And you're like, what? It's print. Why is it not working? This happens a lot of times every year, by the way. I'm just warning you. And you're like, why is that not working? I called the print function. No, what you did is you took the print function and you said, you're not the print function anymore, you're the number 7. So down here you're like, hey, 7, hello. And Python's like, what? What does 7 and hello have to do with each other? So some words, Python, some special words, Python will explicitly disallow you from using. Other things, Python will be like, sure, why not? Shoot yourself in the foot. What do I care? Yeah, that's what you did here. If you ever do this, you're like, well, okay, let me get rid of this line of code, right? I don't know, rerun it. Let's go down here. The damage is done. You can't undo that anymore. You're done. If you ever get in a situation where this happens, or you're suspicious of this happening, there's a simple, just go to runtime, say restart session. Yes. It'll keep all your code. All it's doing is like forgetting everything you told it. And so like you just can rerun it again and you're like, okay, good. I didn't ruin Python forever. It's okay. It's going to happen to you. It's normal. You're learning. Just be warned. You got to be careful with your variable names. And here's another thing too. For those of you with programming experience, you might look at this and be like, but I like the other style, like camel case or whatever, whatever, whatever. One thing with programming is programmers, if you're a good programmer, you're obsessed with conventions. There's this like set of rules that are not, like Python won't not work if you don't follow the rules, but you gotta follow the rules. And if you don't follow the rules, everyone's gonna hate you, especially the marker. Here's the convention. If you have a variable and you want to, like, let's say I'm calculating something, like some bill. I don't know, it's some grocery bill. I don't know, maybe it should be called grocery bill, whatever. But it's 2 words, right? And I can't have a variable with a space in it. I can't say sum bill equals 6. It's not going to work. It's going to say invalid syntax. I can't do that. So we can add spaces by using an underscore. There, and it works. So if your variable has like spaces in it, you use underscores. And all of these letters, listen up, pay attention, everyone, eyes on me. Underscores for spaces, and all of these letters are lowercase. Always, always, always. You can make arguments of like, what if the variable is like 3D, right? So should it be like 3 uppercase D? Is that okay? Sure, those are kind of like funny cases, but in general, always lowercase. Underscores. Okay? Also, another thing I forgot to mention. Your variables have to start also with a letter. They can have numbers in them, but it can't start with a number. It's a funny rule. It's the way it is. So I can say like D3 equals 6, and it's happy. But if I go 3D, it's going to say, you can't, no, that's not. It's just the way it gets parsed. Sorry, it's the way it is. Again, I also know I'm blitzing information at you. I'm just getting you familiar with it. One thing you'll notice in a class like this is I'm telling a lot of things at you, and there's, like realistically, I don't have an expectation that you're going to leave today having absolutely memorized everything I said right now. The point of these lectures are to expose you to it, so when you forget and then you do it and you see it, you go, I feel like I remember something like this, right? It gives you enough knowledge that you can go figure out the rest on your own pretty easily. So don't worry about how am I supposed to remember all this like information overload on me? You're thinking about it all wrong. It's exposure, you listen, you pay attention. When it comes up later, hopefully you go like, I feel like I remember him talking about this. And then you look at your notes or something, which obviously I see everyone's taking notes, which is good. All right, so yeah, sum bill. This is, by the way, this is called a snake case, okay? An alternative popular style, raise your hand if you have experience in like Java or something. Okay. Whether or not people that taught you Java were enforcing these constraints or these conventions, you may or may not have noticed this. But in other languages, and also in Python in certain situations, but in other languages, the convention will be something called like Pascal case or something called camel case. And camel case is like this, right? You use lowercase, but instead of like underscores for spaces, you just jump to an uppercase. Don't do this. You do this in Python, it's going to work just fine. Print sum bill. It's going to work. But the Python gods are watching. And they're unhappy. They're judging you. Okay? And the marker is, consider the marker for the course one of the Python gods. They're going to see this and be like, how much am I going to nail them for breaking these conventions? They're going to get excited because markers are evil people. I'm not the marker, don't worry, it's not me. Someone else is evil, not me. So this will work, but you're breaking convention. Don't do it. In Python, we do use camel case in certain situations, but the point of these conventions is if I see a variable written like this or like this, it actually tells me something about how it's to be used. And I'm going to show you a really good example of that in a moment. Right now. Constants. So, let's say in Python, constants are variables that programmers are going to use in a very special way. So let's say, now there's a lot of reasons why programmers love constants. And constants, they're honestly, as far as Python's concerned, constants are just variables. There's really nothing special about them. They're only special to the programmers. The use of constants means something to programmers. So if you see my code and I give it to you and you see some constants, you know a lot about what's going on. And constants provide a lot of value. But as far as Python concerned, it doesn't care. Functionally, it makes no difference. But the syntax and how we are writing it, like we are actually like applying meaning to these variables in special ways. And here's what I mean with constants. So I've got a variable called some bill, another bill. I look at this and I go, okay, oh, I got up. Ooh, perfect. Because we recently changed the sales tax from the province, right? This is a perfect candidate for the use of constants. So you look at this, think it's like a year ago, right? What sales tax? You look at this and you're like, okay, it's taking some value and applying sales tax, right? And if you're from Nova Scotia and you look at this, you're probably going to recognize what's going on. But let's say you're from like Texas, right, where they don't have any sales tax or anything. And you look at them, they're going to be like, what the hell is this? What's 1.15? What does that mean? Where's that coming from? It's obviously important, but it's like a magic number. And that's actually a word people use. When you've got just this like value, 1.15, and another programmer looks at that value and they're like, okay, obviously it's important, but what does it mean? Okay? Again, this variable named some bill, another bill, it's reasonably well coded. So from the context, maybe you can figure it out. But it's always better to eliminate any guessing. So it's clearly correct. But yeah, what if the government changes the sales tax like they did? So here's what we could do instead. You create a variable called sales tax. Mind how it's written. It's all uppercase, separated by underscores, but all uppercase. As far as Python's concerned, that's just a variable. But you, as programmers, see that and they go, oh, that's a constant. Because that's the convention. And constants are really good because, one, if the government changes, like imagine there's like 1 billion lines of code below this, right? 1 billion lines of code doing calculations where it's applying 1.15, right? There's 2 lines here, multiply that by 1 billion, you got a lot. Sure, in your editor, you can do like Control R to like do like a find and replace, change all the 0.15s to, or 1.15s to 1.14s. But then again, you always risk changing something that shouldn't have been changed, right? So like, although that could work, but there are some risks there. Instead, what you do is you do it like this, and then you say, oh, okay, great, I could just change that to, here, let me do this. I'll just create a new cell down here. Great, it works. Oh, the government changed it? Okay, cool, I'll just do this. Perfect, we're all set. I just changed one little thing, I hit run, everything's working just fine. Cool. So it gives a nice like uniform place to do it. Another thing about constants is it gives you an opportunity to give a name to a magic value. I look at this code and be like, 10.45 times sales tax. Oh, okay. There's no guessing anymore. What was the 1.15? What's 1.14? What does that mean? Well, I can tell you that sales tax means sales tax, but I can't tell you what does 1.15 mean. I'm going to have to maybe guess, connect some dots. This, there's no guessing. Would you agree? So this is a nice way to also avoid magic numbers. You might need magic numbers in your code. You could argue that 1.14 is still a magic number, but we've now assigned a name to it. Oh, and now I know what it means. So, great. But also constant. Why does it need to be a constant? Like, should I have just said like sales tax? The other big key thing about constants is they should never be changed within the code. You set it, and you never modify it. I can say A equals that, and then A equals A times 2, right? That's fine, right? Value of A, and then, oh, I modified the value of A in code, okay? These should never, ever, 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 ever be modified by your code. You can do what I just did. As the programmer, I can change the code, me, but the code should never change its value. I can do this, that's fine. They got to raise taxes, okay, great. I can do that and hit run. But you never ever want to see something like this equals some bill times another bill, right? Something like, obviously that's nonsense, but your code should never reassign the value. But like as it's running, right? I can set it, but once I set it, that's it. I can change it myself, but the program should never modify its value. That's a big thing. As far as Python is concerned, Python will let me do this because Python says it's just a variable. You can do whatever you want with it. But if you're following the conventions, every programmer sees this and goes, don't touch it. Python will let you, but don't do it. In the same way that Python will let you reassign print to something, but you probably don't want to do it. So don't break that rule. Interestingly enough, other programming languages that are maybe a little bit more strict on things, if you set something as a constant and you try to do this, the program won't even run. You're like if it's Java, for example, and you make a constant, and you try to do this, Java's going to go, I'm not running that. You said it was a constant, I'm not modifying it. Python's a little bit more nice, but in its niceness, it lets you screw yourself quite a bit. You had a question? Cool. So yeah, it'll let you change it, but if you're following conventions, you are giving this special meaning. So you know what it means. Even though Python will let you screw around with it, if you're following conventions, we know this actually means something important to us. So constants are pretty cool. They don't come up a lot, but it's important to understand them. You'll have maybe a couple of constants per program at most for like what we're going to do. Cool. Any last questions about these variables and types before we move on? Obviously, we're running out of time, but we can quickly jump into the next topic. Awesome. Okay, oh, by the way, so just a note, there are the lecture recordings that I'm doing right now, but on the YouTube channel, you will find videos from like years ago done in an interpreter, so the environment will look a little bit different, but you might find a lot of value in these things, where these videos are really talking about very specific concepts, and they're much shorter than like a full lecture. So there might be a video on like types and variables, right? But one big warning, for the most part, this is using Python version 2, okay? As far as you're concerned, we're using Python version 3. There was a period of time where these versions kind of existed alongside each other. It wasn't really that 3 superseded it. It was just a change, but the idea was that eventually it would. But this was using Python version 2. And there are like 2 big differences that you will notice in Python 2 versus 3. In Python 2, the prints are like this. You don't need the parentheses. They changed the way prints work. So if you're seeing in Python 2, I'm doing this a bunch, and then you try to do it and it doesn't work, it's the Python 2 thing. All you got to do is this. And it'll work, right? So be warned of that. The other thing you might notice is divide works a little bit differently in Python 2. In fact, a lot of people are really mad about the way they changed how divide works in Python 3 because it actually kind of like breaks how it worked. It broke so many programs, and like every other good programming language did it the way Python 2 did. When Python 3 changed it, it made a lot of people angry. Long story short, I'm going to use special syntax here. Ignore this for a second. I hit run. What's 1 divided by 2? 0.5. No, it's obviously 0. Right? And here's why. This is how like every other programming language would work, and the way Python 2 worked. And you might look at this and be like, why? Here's why. Because the integer 1, the operator divide, and the integer 2, if you have an integer, I want to get an integer back. Now, what do we do with the decimal? It truncates. It doesn't round, it truncates. This value could be 9 divided by 10. You're going to get 0. The value could be 0.9999999999999, but it'll always get truncated down to the lower value. So this is integer division, okay? And it makes perfect sense to programmers, and a lot of programs take advantage of this type of thing. But it's integer division where if an integer, I want an integer back. And if you really wanted a decimal back, you would just do something like that. You make one of them a float, and it'll go like, okay, fine, I'll make it a float. Easy peasy, everyone was happy. Then Python 2 came along and was like, no, we're going to change it to just take an integer and give you a float back. And you might not think that's a big deal, but it is. Anyways, more on that later. If you want integer division in Python 2, in Python 3 you do //. Everyone felt like if you wanted to do it, you'd flip it. Long story short, if in the videos you see division acting weird, that's probably why. All right, I'll catch you later.